Hello everyone. In this we will see what is meant by incidence matrices and how to represent these incidence matrices for a given graph. The name incidence indicates that meeting. So first let us try to understand incidence matrix and later we will see how to form the incidence matrix. Element node incidence matrix which is represented by A cap. Here the first term element refers to the number of rows and the number of nodes represents the number of columns. So that means the size of A cap matrix will be equal to number of elements to the number of nodes. In this subject, the same nodes only we are calling it as a buses. So here the number of nodes will be equal to the number of buses. So first point, and whatever the lines which we are using to connect the nodes will be called as a number of elements. I have called you this as a number of branches. So hereafter we are using the total number of lines present in the graph will be equal to the number of elements. Okay. So here I have, let me consider 3, 4, 5 and 6. So if you consider here the total number of elements, those are nothing but the total number of transmission lines present in this graph will be represented by small e, that is equal to 6 elements. Okay, if you say number of branches, those number of branches will be meant for the tree branches. Okay, so if I say it as a number of branches, that will be equal to tree branches. With respect to these notations, I can say the number of links L is equal to E minus B, where E is the total number of branches present in the graph and B is the number of branches of the tree, where L is the number of links. So this point you can make a note of it. Right. So now with respect to our element node incidence matrix, the size of the A cap matrix is nothing but E cross N. Now let us see what are the points that we need to consider while forming the element node incidence matrix. The incidence of nodes in a connected graph is shown by the element node incidence matrix. So as name suggests, incidence means meeting. So according to this point, the incidence of the nodes in a graph is shown by the element node incidence matrix. What is meant by the incidence of the nodes? That means if you take a particular node in the graph, how many number of transmission lines are connected to this? Okay. How many number of transmission lines are connected to this. So it may be one transmission line, it may be two transmission lines, it may be n transmission lines also. So which are called as a elements. Okay. How many number of elements that are connected to a particular node will form this element node incidence matrix. We will be checking each node and we will look for how many elements are incident to this node. So how many elements are connected, those transmission lines will have some value. Let us see what is that value and how to give the values for the connected elements. Coming to the second point, the dimension of the matrix is E cross N that we have discussed already, because E refers to the number of elements and N refers to the number of nodes. Now coming to the elements of the matrix, the first point is Aij is equal to 1 if the ith element is incident to and oriented away from the jth node. Okay. And Aij is equal to minus 1 if the ith element is incident to and oriented towards the jth node, and Aij is equal to 0 if the ith element is not incident to the jth node. So don't worry, we will see one by one. Aij is equal to 1. What does that mean? Aij is the element value. Okay, Aij is the value of the ith element which is connected to the jth node. So first let us try to understand this first point. I am considering a node which I am calling it as a jth node. Okay, and I am taking an element which I am calling that as a ith element. What is meant by ith element? It is a transmission line. Okay, this is a bus and I am considering a transmission line. I am calling it as an ith element. Suppose if this transmission line is connected to this node, okay, it should be incident to this node. What is meant by incident to? Connected. Okay, if my ith element is connected to this node, and if you consider the direction of this transmission line, okay, the power flow, if you look at the power flow or the current direction, if the direction of this particular element will be away from the node, then this ith element value will be equal to 1. Is this clear? So now if you read this point, you can understand if the ith element is incident to the jth node and the oriented away from the jth node, if they directed away from the jth node, then that value carries 1. Now coming to the second point, again you consider a jth node and an ith element. If this ith element is incident to, that means again it has to connect it to this jth node, and if the direction is towards the jth node, then that particular element value will be equal to -1. Now coming to the third point, if you consider a jth node and if you consider an ith element, if it is not incident to this jth node at all, then that value will be absolutely equal to 0. Okay, we are forming an incidence matrix, means if there is any incidence, if there is any meeting or connection between the transmission line and a bus or the node, then only that will carry the 1 value, either plus or minus value. When we will get a plus value means if the direction is away from the node. If the direction is towards the node, then we will get the value -1. If the line is not at all connected to the jth node, that value will be equal to 0. So now you can represent all these three conditions as Aij equal to 1, Aij equal to -1 and Aij equal to 0. So I hope this is clear. Let us consider the graph shown below. For this, we need to form the incidence matrix, element node incidence matrix A cap. If you are experienced just by looking at the graph, we can write the element node incidence matrix. Since we are new to this concept, so let us go step by step. So once you understand the concept, you could be able to form the incidence matrix just by looking at the graph. So let us represent this as a matrix A cap, which is the element node incidence matrix that we are going to form between the number of elements to the number of nodes. Okay, the rows position represents the number of elements and the columns position represents the number of nodes. Okay, how many number of nodes that we have here? We have 4 nodes, 0, 1, 2 and the 3. Remember, always the nodes will be represented by an encircled numbers. Okay, number which is encircled. This represents the node. The branches will be represented by the number without any circle. So this difference we should show in the low flow studies. Now let us represent the number of elements row wise. So we have 6 elements. So let us mark those elements 1, 2, 3, 4, 5 and 6. And coming to the number of nodes, that we have 4 nodes, 0, 1, 2 and 3. Whenever we are forming any incidence matrix, we should fill the numbers with respect to the node wise. That means we should see first 0 node. So how many transmission lines are connected? Based on that, we should fill up these matrix values. Now let us see. First I am going to consider the node 0. How many transmission lines are connected to this node means we have 3 transmission lines directly connected to 0 node, that is first transmission line, second and the third transmission line. So let us consider 1, 2 and 3. All these 3 transmission line carries the value 1, but whether it is a +1 or -1 will decide by the direction. If you take the first transmission line, the direction is towards the node. Since it is the towards the 0 node, this carries -1. So we have represented the element 1 with respect to node 0 is -1. Now, coming to the second transmission line. So if you see the direction, this is also going towards the node. So this also carries, that means second element with respect to reference node will be -1 again. Now coming to the third transmission line, the direction of the third transmission line is also towards the 0 node. So this value also carries -1. And only 1, 2, 3 are incident to the 0 node. Remaining transmission lines, that is 4, 5, 6 are not connected to the 0 node at all. So the 4, 5, 6 values will be represented by 0. Now we have finished the node 0. Now we have to look at the node 1. Now let us take the node 1. And how many transmission lines are connected to node 1 directly? So incident to, if you look at this point, we will come to know. So how many elements are connected? 3 elements are connected, 1, 4 and 6. So 1 already we have taken, and the 4th transmission line and 6th transmission line. I have highlighted the transmission lines which are connected to the first node. And if you look at the direction of the first transmission line with respect to the first node, the direction of the first transmission line is away from the node. So this value carries 1. Okay, with respect to the first node, element 1 value will be 1. Then coming to the fourth element direction is towards the first node. So therefore that value carries -1. So what is that? You have to go to that respective one. This is the fourth element with respect to the first node. Here you have to fill -1 value. Now coming to the sixth transmission line. Sixth transmission line with respect to the first node. What about the direction? The direction is away from the first node. So that value will be equal to 1. So remaining values we have not represented, means those transmission lines are not connected to the first bus. So the line numbers 2, 3 and 5 will be equal to 0. So I have represented remaining values as 0. Okay. Now coming to the second node. So second node, we have line numbers 2, 4 and 5 connected to the second node. So 2, 4 and 5. Now if you look at the direction, the second element direction is away from the second node. So that carries the value 1. And coming to the fourth node direction is also away from the second node. So it is moving away from the node. So that value also will be equal to 1. And the fifth transmission line direction is also away from the second node. So remaining values will be equal to 0. Now coming to the third node, 3, 5 and 6 are connected. Third transmission line direction is away from the third node. So that value will be equal to 1. And fifth element direction is towards the node, and the sixth element direction is also towards the node. So that means the element number 5 and element number 6, both the directions are towards the third node. So 5 and 6 carries -1. So you can see here I have filled -1 and remaining values will be equal to 0. So this is how we have to form the element node incidence matrix for a given graph. Since the number of rows represents the number of elements and the number of columns represents the number of nodes, the size of the matrix will be equal to E cross N, where E is the number of elements and N is the number of nodes. So I hope this is clear. And coming to the bus incidence matrix, the other important matrix that we need to know is bus incidence matrix. You can write this bus incidence matrix as element bus incidence matrix. So as however you have seen, only the difference is there we have taken element node incidence matrix. Instead of node, I have taken element bus incidence matrix. What is the difference between the node and bus? Okay, you may get doubt just now, you have told that you can call the same node as a bus also, right? That is true, but there is a slight difference. Why we have used instead of the node as a bus means in this load flow studies concept. So what we will be doing is, suppose if our network is having 4 nodes like this, one of these node will be considered as a reference node. Okay, one of this node will be considered as a reference node. This I will tell you in the later sessions what is meant by reference node and for what we will use this reference node, all those things. Okay, one node if you consider as a reference node, the remaining nodes will be called as a actual buses. In a general term, you will call it as all our buses only. This also you will call it as a reference bus. Instead of the reference node, you will call it as a reference bus. Okay, if you take total number of buses equal to 4 buses, okay, out of this one will be considered as a reference bus and remaining 3 buses will be called as a actual buses. Okay, so if you consider n buses, among these n buses, we will consider one bus as a reference bus and n minus 1 buses you will call it as a actual buses. So in that context, we have taken that matrix as a element bus incidence matrix. That means the size of the element bus incidence matrix will be equal to number of elements to the n minus 1. Suppose if you take number of buses as a 4 and the number of elements as a 6 element, then the size of the A matrix will be equal to 6 cross 3 matrix. So now let us see how to form the bus incidence matrix. Any node of a connected graph can be selected as the reference node. So as I told you, if you have a n nodes, pick any one among the n buses as a reference bus. So that we will see what are the points that we have to consider to select bus as a reference bus. Right now, it is not necessary for us. You remember, out of the n buses, we will select one bus as a reference bus. Then, the variables of the other nodes referred as a buses and can be measured with respect to the assigned reference. So now coming to this, how to form this incidence matrix means, you know that we have formed the A cap matrix based upon the number of elements to the number of nodes. Suppose let me say I have considered all my nodes present in the graph. Now, whatever the nodes we will consider as a reference node, I may be considering the 0 node as a reference node, or first node as a reference node, second node as a reference, or third node as a reference. So whichever node I am considering it as a reference, if you delete that respective column from the A cap matrix, the resultant matrix will be called as a bus incidence matrix A. It is very, very simple. If you understand the formation of the A cap matrix, the A matrix is nothing but if you delete the column with respect to the reference node, that will be equal to the A matrix. Suppose if I consider the 0 node as a reference bus, then if I delete the corresponding column with respect to this 0 bus, if I delete this column from that matrix, then the matrix which is formed between the number of elements to the buses 1, 2, 3 will be called as A matrix. Okay, this A cap will be transformed into A matrix if you delete the column with respect to the reference node. Therefore, the size of the A matrix will be equal to E by n minus 1. So that n minus 1 is nothing but deleting the column corresponding to the reference node. So now let us see the graph and the corresponding bus incidence matrix by selecting the node 0 as a reference. So this is the graph. So we are selecting 0 node as a reference node. So the nodes 1, 2, 3 will act as a actual nodes. Therefore, the matrix A can be represented like this. So already here we have formed the A cap matrix. From this, if you delete this respective column from this matrix, then the resultant matrix will be called as a matrix. So that is what we have formed here. We have deleted the reference node 0. So the resultant will be E cross n minus 1. So the size of the matrix is E by n minus 1. I hope it is clear. Thank you.